This lesson focuses on solving systems of equations that have special solutions. For example, infinite and no solutions. Now, we have already learned that there are three methods of solving a system of equations. Let's just quickly take a look at all three methods so that you can see a comparison of them. Substitution is when you get one variable all by itself. You're going to take that one variable and you're going to put it into the other equation. So x plus 1 is the exact same value as y. So whatever y is, x plus 1 is the same number. For example, if y is 50, then x plus 1 is also 50. Because of that, because they have the same value, you can take the y out and replace it with x plus 1. So now we have x plus 1 equals 5. 2x plus 1 is 5, which means 2x is 4, which means x must be 2. To get your y value, you're going to take it and put it into either one of the originals. I like this one. So now I'm going to take the 2 and I'm going to put it right in for x. So y is equal to 2 plus 1. So that means y is equal to 3. Okay, so now let's take a look at the addition method. To do the addition method, or even subtraction, what we need to do is we need to first line things up. Remember, with addition or subtraction, you always have to have things lined up. So I think what I'm going to do is I think I'm going to bring this x over to the other side. So now I end up with negative x plus y equals 1. And I'll bring the other equation right underneath there, which is x plus y is 5. And the next thing you want to look for is opposite coefficients, which I have with the x's. So when I go ahead and add them, I end up with 2y is 6, which means y must be 3. And to get my x value, I can plug it into either of the equations. So I'm going to take that 3 and I'm going to put it right in here for y. So x plus 3 is 5. So what plus 3 is 5? Well, that must be 2. Okay, our last method, which is graphing. Okay, with this one, you need to get both equations in y equals mx plus b. So your first one is already set. That should be an easy one to graph. Your next one is going to be y is equal to negative x plus 5. Okay, so let's graph both of those. So your first one, put a dot at 1. Your slope is 1 over 1, so up 1 over 1. Okay, I'm going to draw a line here. I am also going to label it. I'm going to draw my next line, which has a dot at 5. And your slope here is negative 1 over 1. That means down 1 over 1, down 1 over 1. There's your solution. Connect your dots. And clearly, I can see that my solution is the same as what I found using the other methods. So the solution is 2, 3. Okay, so now let's talk about what can happen, the special types of solutions. Now you can solve these any way you want, but I think a good visual is to look at the graphs. Well, when you graph two lines, they can cross. And if they cross like this, you have one solution, just one answer. There's one point that works in both equations. Okay, well, if we call it one solution, just to give you the type of system it is, we would call that a consistent system. I don't care if this is something that you memorize or not, but it is a consistent system. Okay, the other thing that could happen here is we could have two lines that are parallel. And if they're parallel, that means they will never cross. This means you have no solution. Now, if a consistent system has one solution, then we call one with no solution an inconsistent system. Okay, and the last thing that could happen is you could graph both lines and they could sit right on top of each other. And this would mean we would have infinite solutions. And we call that a dependent system. So it could be consistent, meaning they have one answer in common. It could be a no solution, which means there are no points that are in common with both lines. Or they can have all the points that are on the line, and you know a line is made up of an infinite amount of points, so we have infinite solutions. Now the tricky part is, what's it going to look like when you solve a system algebraically? So we're going to solve this algebraically, and we're going to see that this should come out to be an inconsistent system. Given the way they're lined up, I'm thinking probably the easiest method would be addition or subtraction. Now, if I can, let's say I want to get rid of the x's. If this is a positive 2x, I want this to be a negative 2x. So what I'm going to do is I'm going to just subtract the bottom. If you want to look at it as multiplying the bottom by -1, you go ahead and you do that. It's the same thing. Now I end up with 2x minus 2x, which is 0, y minus y, which is also 0. That leaves me with nothing on the left. On the other side, I end up with 5 take away 1, which is 4. Okay, so when does 0 equal 4? Never. This is never true. What this means is this is a no solution. If I were to graph these, and maybe you can imagine putting it in slope-intercept, they have the same slope. If they have the same slope, they're going to be parallel, particularly if they have different y-intercepts. You want to look at the y-intercepts because that does make a big difference. If they have the same slope and the same y-intercept, they're the same line, and therefore that would be infinite solutions. But if they have the same slope but different y-intercepts, that's no solution. Okay, so now let's look at something that has many solutions. Since I did the last one with the addition-subtraction method, I think what I'm going to do on this one is substitution. So I'm going to bring the 2x to the other side, so we have y is equal to 2x plus 3. Now I'm going to take that. It's the expression 2x plus 3 is the same thing as y. I'm going to put it right in here. So I have negative 4x plus 2 times 2x plus 3 equals 6. Let's use our distributive property here. And these two total 0. So we end up with 6 equals 6. Well, when does 6 equal 6? Always. That's always true. So this is an example of infinite solutions. If I were to graph this, you would notice that these are the exact same line. So if you were to put both of those in y equals mx plus b, they would be the same thing. And then, of course, we have consistent system, which means you have one solution. And I'm not going to model any of those because we've had several days of practicing how to solve those. Okay. If you would like to do this section, you can, but I'd like you to practice by solving using any method. So feel free to pause the video, solve it, and then unpause it to check. Okay, pause it now if you want to try this. Okay, so if you did this, you should have had an answer of 2, 2. So this would be an example of a consistent system. Let's try another one. Okay, pause the video now to try it, and let's see what you come up with. Okay, so I came out with infinite solutions on this one. So if I multiply the top by 3, I now have opposite coefficients for both the x's and the y's. They cancel, and I get 0 equals 0. Just so that you know, there are multiple ways of solving this. I happen to choose the addition method, but a method that I've used before in the past was I've actually done this where I've divided both sides by -3. And if I divide both sides by -3, you might happen to notice that I end up with 2x plus y is equal to 5. It is the exact same equation as the top one. And if they're the same equation, they're going to graph the same line, and therefore it's going to be infinite solutions. So there's lots of ways to solve these. My method was to do addition method, but keep your mind open. There's a lot of ways you could do this. All right, let's try one last one. Pause the video, and let's see what you get. Okay, in this one I came up with a no solution. And you can clearly see that I chose to do the addition method. All right, if you are feeling as though you are ready to try this on your own, great. There is a worksheet on my website that you can either print off or do on your own piece of paper. It's going to ask you to solve a system using any of the methods that we have. There is an answer key attached, so you can take a look at it. Again, email me if you have any questions or concerns. We can run through anything. Feel free to watch the video again, and good luck to you. Please email me if you have any questions.